going to be looking at some properties of logs, but before we do that, you'll notice at the top of your paper, they do tell us that there's a certain mode or something that we've got to do within that mode. So everybody go to your calculators and go to mode for me. And right below normal, you'll notice that you've got float highlighted. What we're going to do is we're going to change that to 1. What we're going to do is make sure that all of our decimals that we get today, that they're rounded to 1 decimal place. That's what that 1 highlighted means, okay? Right now it's set to float, which basically means that it's going to give you as many decimal places as it can. We want just 1 decimal place. All right, so once you fix that mode, we're going to go ahead and go to the clear screen, and we're going to find out what the log of 5 is. So go ahead and type that in. What is the log of 5? 0.7. Remember, it rounded it 1 decimal place, and that turns out to be 0.7. So go ahead and write that down for me. Now let's find out what the log of 50 is. What is the log of 50? 1.7. Very good, 1.7. And then let's go ahead and do log of 100 as well. What is the log of 100? 2.0. Which is the same thing as a 2. All right, so we've just found out the log of 5, the log of 50, and the log of 100. What we're going to do is we're going to use those numbers here in a second. Number 1 says, based on these answers that we just came up with, you can also determine log of other numbers. And that's what we're going to be doing here. So you'll notice the first thing they give us is the log of 5,000. Well, if you think about it, the log of 5,000, how do I get a 5,000 using either a 5, a 50, or 100? Well, in this particular case, wouldn't I get 5,000 if I multiply 50 times 100? We all agree that 50 times 100 is 5,000. Okay? So what I'm saying is that log of 5,000 is the same thing as log of 50 times 100. They're equivalent. They mean the same thing. So let's go ahead and go to our calculator. Let's find out what is the log of 5,000. Put that in your calculator. What is the log of 5,000? What's that? 3.7. 3.7. You can write that down. 3.7. Let's go to the next one here. The log of 500. How can I get the log of 500, or how can I get this 500 using a 5, a 50, or a 100, or a combination of two numbers? 5 times what? Very good. So that would be the same thing as the log of 5 times 100. If you multiply 5 times 100, you're going to get 500. So they're equivalent. They mean the same thing. So what's the log of 500? 2.7. 2.7. By the way, remember, they're rounding all of our decimals to 2 decimal places. So there are other decimals you just don't see. All right, let's do log of 250. How can I get 250? What two numbers can I multiply together to get 250? What's that? 5 and 50. All right, so log of 5 times 50 would be the same thing as log of 250. And what is the log of 250? 2.4. Okay, 2.4. The next one, log of 20. Log of 20. What two numbers can I multiply together to get 20? Remember, I'm looking at 5, 50, and 100. Are there two numbers that I can multiply together to get a 20? No, that just can't happen. But I can get a 20. Anybody know a way we can get a 20 using either 5, 50, or the 100? Divide. I mean, what two numbers are you talking about? Divide. What's that? 5 and 100. Which one goes first, though? 100. 100 divided by 5 would give us a 20. All right, so that would be the equivalent of the log of 20. All right, so the next question is, what is the log of 20? 1.3. Log of 2. Notice there's no two numbers that I can multiply together to get 2. But if I use division, I can get 2. The question is, what two numbers can I divide to get that 2? 150. If I divide 100 divided by 50, would I get a 2? Okay. So that's equivalent. So the log of 100 divided by 50 is the same thing as the log of 2. And what is the log of 2? 0.3. And then the last one there, log of 10. What two numbers can I divide to get log of 10? What's that? 50 and 5. Therefore, the log of 10 is equivalent of log of 50 divided by 5. And the log of 10 is 1, or 1.0. All right, so let's take a look at this another way. Over here on the right, they want us to rewrite it in terms of the 0.7, the 1.7, and the 2. That's those three numbers that we got up here earlier. Remember, we said the log of 5 is 0.7. We said the log of 50 was 1.7. And we also said the log of 100 was a 2. So these are the three numbers they're referring to. So, if log of 5,000 is the equivalent of log of 50 times 100, then, well, let me do it this way. Then we have log of 50. I'm just separating these over here. Then the log of 50 plus the log of 100 are also equivalent. And here's what I'm talking about. This log of 50 right here. Didn't we say log of 50 was 1.7? Isn't that what we said earlier? This log of 100 right here. What did we say log of 100 was earlier? We said it was a 2. Guess what you get when you add those two numbers together? You get your 3.7. Okay? Let's try that again. Look at the next one. Log of 500. We said log of 500 was the same thing as log of 5 times 100. So, that right there is also equivalent to the log of 5 plus the log of 100. So again, all I'm doing is taking both of these numbers that are in the parentheses, the 5 and the 100, and I'm separating them. I'm making two logs. Okay? Log of 5 plus the log of 100. Watch this. Log of 5. Again, log of 5 we said earlier was 0.7. We said that the log of 100 was 2. And what do you get when you add those two numbers together? You get your 2.7. Look at this one over here. Log of 5 times 50. That can also be written as log of 5 plus the log of 50. This log of 5 right here, we said was a 0.7. This log of 50, we said was 1.7. And what are you going to get when you add those two numbers together? You're going to get your 2.4. It's a little different on the next one. Here we have log of 20. And we said to get that 20, we had to divide two numbers. And the two numbers we were dividing are 100 and the 5. 100 divided by 5 is 20. So it's a little bit different. This time it's subtraction. So now we've got log of 100 minus the log of 5. Log of 100 minus the log of 5. Again, I'm separating those two over there. So earlier we said the log of 100 was a 2. We also said the log of 5 was 0.7. So if I subtract those two numbers, 2 minus the 0.7 gives us this 1.3. Which of course means the same thing would happen on the other two. Alright, so that log of 100 divided by 50 can also be written as the log of 100 minus the log of 50. And since the log of 100 was a 2 and the log of 50 was the 1.7, what do you get when you subtract those two numbers from each other? You get your 0.3. And then the last one, same exact thing. That log of 50 divided by 5 can also be written as the log of 50 minus the log of 5. And since the log of 50 was 1.7 and the log of 5 was 0.7, if you subtract those two numbers, you're going to get a 1. So, what pattern occurs? What rule can we develop? Here's what I want you to write down for me. The logarithm of a product, that's referring to the first three that we saw over here, product. Product means multiply. The logarithm of a product is the same as the sum of the individual logarithms, which is what we got over here on the far right-hand column. We separate them as individual logs. So the product highlight those key words for you. The product is the same as the sum. The product is the same as the sum of the individual logs. But the last three that we saw, a little bit different. Here we have the logarithm of a quotient is the same as the difference of the individual logs. So the division is the same thing as the subtraction. Division is the same thing as subtraction. The product is the same thing as the addition. All right, let's take a look at the next section, a little bit different here. On the next section, we're going to be looking for a pattern. The first thing they give us is the log of 5 squared. Well, first of all, what is 5 squared? 5 squared is a, what guys? 25, which is what we have right here, log of 25. So this and this are the same thing. So the question is, what is the log of 25? Put that in your calculator for me. What's the log of 25? 1.4. Okay, so write that down for me, 1.4. The next one we have is the log of 5 to the third power, or 5 cubed. Well, what is 5 cubed? What is 5 to the third power? It's 125. So what is the log of 125? 2.1. Log of 5 to the fourth power. Well, 5 to the fourth power is 625. And what is the log of 625? 2.8. Next one we have is log of 5 to the fifth power. Well, 5 to the fifth power is 3,125. And what is the log of 3,125? 3.5. And then the last one there, log of 5 to the sixth power. Well, 5 to the sixth power is 15,625. And what is the log of 15,625? It is 4.2. All right, so now that we know the answers, let's take a look over here. It says, how do each of our answers compare with a log of 5? Well, first of all, what was the log of 5? It's on the first page, guys. What was the log up at the top? It's 0.7. It's right here, 0.7. So again, how does each answer compare to log of 5? So notice over here we had log of 5 squared, and we got an answer of 1.4. So how does that compare with log of 5? What do you notice? We went from a 0.7 to a 1.4. Huh? So in this particular case, we multiplied by 2. Okay. So what we're doing here, in this particular case, the first one, it got twice as big. We started with 0.7. That was log of 5. All we did was make it twice as big. In other words, we took that 0.7 and we multiplied it by a 2. That's how we came up with our 1.4. Well, look at the next one. The next one, the answer we came up with was 2.1. How does that answer compare with the log of 5, with that 0.7? Y'all notice anything? How did we go from a 0.7 to a 2.1? What's that? Times 3. Notice it's 3 times as big. In other words, we're taking our 0.7 and we're multiplying it by a 3. 3 times 0.7 is 2.1. What about the next one? How did I get that 2.8? How did we go from a 0.7 to a 2.8? Well, this one got 4 times as big. In other words, we took that 0.7 and all we did was multiply it by a 4. Y'all noticing a pattern here, right? Yeah. What's going on? What are we doing? Multiplying by x bar. Yeah. All we're doing is taking what and multiplying it by the x bar? The 0.7. And why the 0.7? Because that's what the log of 5 is. Okay? So on this one, it's 5 times as big. In other words, we're multiplying the 0.7 times the 5. And then that last one over there, it got 6 times as big, meaning that we multiplied the 0.7 times the 6. And that's how we came up with that 4.2. So, if that's true, and I already give you this right here, the log of 5 to the 8th power. Do I really need to find out what 5 to the 8th power is? Do I really need to write out this big, long number there? No. All I really need to do is come over here and take my 0.7 and multiply it by a what? An 8. So do that for me. What is 8 times our 0.7? 5.6. Okay. So no, we don't actually have to work that out. All we're doing is multiplying by the exponent. That's all we're doing. All right, so describe the pattern that we see here. Here it is. When the exponent inside the log, and that's referring to that 2, 3, 4, 5, 6 exponent that we saw. When the exponent inside the log increased by 1, the answer also increased by 0.7. So if you look closely at all these answers here, notice all we're doing is increasing each one of them by 0.7. That's one way to look at it. Another way to look at it is the exponents inside the log can become the factor on the outside of the log. In other words, that exponent is what we multiplied by. So we took the 0.7, multiplied it by a 2, then we multiplied it by a 3, then a 4, then a 5, then a 6. That's all we're doing. It's the number that we're multiplying by. All right, so what we're going to do on the next page is we're going to summarize what we just found out on this first page. All right, so turn the page, and let's summarize what we just found out. So here's the first one. Up at the top, we have log base b of x times y. What did we say about multiplication? Multiplication was the same thing as what? Adding. Okay, so this right here can also be written as individual logs with addition in between. All right, so in other words, we can rewrite this as log base b of x plus log base b of y. Log base b of x plus log base b of y. So again, the log of a product is the same as the sum of the log of the numbers. Multiplication inside a logarithm can change to addition on the outside. So remember, multiplication, addition, multiplication, addition. Now the next one there goes to division. The next one says that log base b of x divided by y. What do we say about division? Division was going to be the same thing as subtraction. All right, so this can be written as log base b of x minus log base b of y. So we can write these as individual logs and subtract. So the log of the quotient is the same thing as difference. And division inside a log changes to subtraction on the outside. And the next one down there, that's the last one that we just got through looking at, log base b of x to the p power. What do we say we were going to do with that exponent? That exponent is what? It's what we are multiplying by. Okay? So this right here now becomes p times the log base b of x. That exponent is what we're multiplying by. So over here it says log of a number raised to a power is the same as the power times the log of the number. A power inside a logarithm changes to multiplication on the outside. That exponent now becomes multiplication. That's what we just saw in the last few examples that we saw. So these three things here summarize what we just saw on the first page. Now you'll notice there's two more down there at the bottom. We really haven't seen any like that. So let's take a look at those last two. First one says that log base b of b to the p power is equal to what? Well, the first thing I want to point out is notice that our base here and our argument are the same. In other words, if these two things are the same, the answer is going to be our exponent, p. P. That's it. So, for example, over here, notice how the base and the argument are both 2. And because they're both the same number, all we're going to do is keep the exponent. And what's the exponent in this case? It's a 6. All right, so as long as the base and the argument are the same, all you're going to do for me is keep the exponent. Okay. So if that's true, what about this one over here? What do you notice about the base and the argument? They're the same. So what did I just say? We're going to keep the exponent. So what's the exponent on this thing? 1. Guess what the answer here is? 1. So you look, they give us another example, very similar. Notice how the base is 2, the argument is 2, and because they're the same, there is no exponent. Well, actually there is. You just can't see it. It's a 1. So the answer there is 1. All right, let's turn to the next page and let's take a look at some examples. Now, what I want you to do first is calculators, turn them off, put your lids on, because we're going to do these without a calculator. It's that easy. Turn off the calculator, put your lids. All right, so it says first we're going to try these without a calculator. Then once we get the answers, then we'll go back and check to see whether we got it right or wrong. So here we go. First one, A. Here it tells us that the log of 2 is 0.30. It also tells us that the log of 450 is 2.65. Well, if that's true, what is the log of 900? Well, first thing you got to do is figure out, how did I get this 900? What did I do with this 2 and this 450 to get a 900? Can anybody see it? You multiply it. And what did we say earlier about multiplication? That is going to be the same thing as adding. Okay, so guess what? Guess what we're going to do with these two numbers right here? We're going to add them together. So we're going to take our 0.3, and all we're going to do is add 2.65. Now, you don't need a calculator. What do you get when you add those two numbers together? 2.95. We'll check to see if that's right or wrong here in a minute. All right, the next one. The next one says that the log of 6 is equal to 0.78. The log of 11 is equal to 1.04. So if that's true, what is the log of 66? Well, first of all, this 66. How did we get that 66? What did we do with this 6 and this 11? We multiplied it. And what did we say earlier about multiplication? It was going to be the same thing as adding. So guess what we're going to do with these two numbers right here? What are we going to do with them? Add them together. So what do you get when you add 0.78 plus 1.04? 1.82. All right, we'll check that in a minute. Let's go to the next one. The next one we have is the log of 36 is equal to 1.6. The log of 3 is equal to 0.5. And we want to find out what's the log of 12. Well, first we got to figure out, how did I get log of 12? What did I do with this and this number here? We divided it. So what did we say earlier about division? That it was going to be the same thing as subtraction. So what are we going to do with these two numbers right here? We're going to subtract them. So 1.6 minus a 0.5 would give us a 1.1. And the last one here is the tricky one. If the log of 11 is equal to 1.04, then what is the log of 112? So how did I go from this to that 121? What did we do here? We times it by itself, or we squared it. Okay, so really what we did was we had log 11 squared. Okay. So what did we say earlier? What did we say earlier about that exponent? It's going to be the same thing as multiplying by that number, right? So what are we going to do? We're going to take the 1.4 and we're going to multiply it times what? 2, the exponent. So what do you get when you multiply 2 times that 1.04? 2.04. 2.08. All right, now let's check it just to make sure. By the way, notice up here at the top it says use a calculator with decimal mode set to float. So go ahead and go back to your mode button. Right now we got it set to count or to round our decimals to one decimal place. I want you to change it back to floats. Change it back to floats. And let's check the first one. Let's find out the log of 900. Put that in your calculator. Log of 900. Now remember, now it's set to float. So now it's going to give you a lot of decimals. But we should get something pretty darn close to 2.95. Is that true? Yeah. Let's check the next one. Log of 66. Is that pretty close to 1.82? Yep. Okay. How about log of 12? Is that pretty close to 1.1? Yep. And the last one, log of 121. Is that close to 2.08? Yes, it is. Okay, so we got our right answers. So you just got to remember that the multiplication is going to be the same thing as addition. The division is going to be the same thing as subtraction. And when we're squaring, or when we have that exponent, that's the number we're multiplying by. All right, let's go to the next section here. Here it says for us to rewrite each logarithm as a single expression. So the first one we have here is log of 2 plus the log of 5. Well, again, what did we say earlier? Addition was going to be the same thing as multiplication. So what are the two things I'm going to multiply? The 2 and the 5. What do you get when you multiply 2 times the 5? 10. So the answer to this E is up here at the top. Which one is it? The first one, log of 10. All right, so there it is. There's our answer. All we did was multiply 2 times 5. F, a little bit different. This time we're subtracting. And what did we say earlier about subtraction? That it was going to be the same thing as division. So we're going to take these two numbers right here and divide them. So 500 divided by 5 would be 100. So which one of these is the correct answer? Bottom right. That's log of 100. Now G looks a lot different, but it's actually the same thing as F. Very, very similar to F. We're subtracting. And what do we say about subtraction? Division. So what are we going to divide? X by 10. We're going to divide X by 10. So which one of these answers up at the top shows us dividing X by the 10?
Top right.
Top right-hand corner. This one right here. By the way, notice that we're keeping the same base. We're keeping that base of 5. That doesn't change. All right, H. H, here we have 2 times the log base 3 of X plus 1. Now notice there's a 2 in front here. Anybody remember what we said about the 2? It's the exponent, right? So this can also be written as X plus 1 squared. Anybody know what you get when you square the X plus 1? X squared plus 2X plus 1. Remember, you got to use FOIL method. FOIL method. That's what we get. And I is very similar to H, except this time the exponents at 3 that we're multiplying by here now becomes the exponent. So what do I get when I take 2m to the 4th power to the 3rd power? I get this thing right here. Notice how 2 to the 3rd power would give me the 8. Notice how 4 times 3 gives me this 12 right here. We okay? You with me? All right, one last thing to look at. This part down here. Notice those last 2 rules that we looked at. J, notice how the base and the argument are the same. We got a 5 and a 5. What did we say earlier? If they have the same base and the same argument, it's going to equal to the exponent. And that exponent on this one is a 7. So the answer here is 7. Same thing on K here. Notice how the base and the argument are the same, 6 and 6. So we're just going to keep the exponent. And what is that exponent? 1. Now what about the next one? Log of 10 to the negative 4th power. Are the base and the argument the same? Yes, remember, if we don't see that base, It's that common log. It's that 10. All right, so the base and the argument are the same. So all we're going to do is keep the exponent, and that exponent is a -4. And the last one here, this one's the trickiest one. This one has to be done in 2 steps here. Notice we have log base 12 of 3 plus log base 12 of 4. The first thing I'm going to do is rewrite this, guys. Notice we've got some addition here. So if I want to combine these two, we said addition was the same thing as the multiplication. So I'm going to multiply the 3 and the 4. And if I multiply that 3 and the 4, I'm going to get a 12. Right? So this right here is the same thing as log base 12 of 12. So what are we going to get? What do you notice about the base and the argument? They're the same. And what do we know if they're the same? We keep the exponent. And that exponent is a 1. So the answer there should be 1. All right, so that takes us through our notes.